Okay, so we are looking at section 2.4. So hopefully you have your notes in front of you. Maybe you're watching this on your phone and then you can have your notes in front of you on your iPad. So I'm going to do a flip lesson. So I'm going to teach you the lesson in a video or a couple of videos because it might take too long to put it all in one. And then you are going to work in class when you come to class with me. So you can actually work on the worksheet in class. So in section 2.4, we're looking at polygons. So we're still looking at angle properties, but we're looking at angle properties in polygons. However, we're only going to look at angle properties in convex polygons. Okay, so convex polygons, if you look at the very first diagram, you can see that all of the angles inside that polygon have angles that are less than 180 degrees. So none of them are straight lines. If you look at the other diagram, so right here, you're going to notice that this particular angle inside, we would actually say that that's a reflex angle that's greater than 180 degrees. So this is a concave polygon. We're not going to be talking about any of those. All right. So I asked you guys to actually start with the investigation and to fill in that table. And to help me do the investigation with you, I have drawn the first 6 shapes on the sides of my pages. So what's asked you to do is actually to ask you to draw the polygons listed below and create triangles inside them. So see how many triangles you can actually create. I probably should have done one little extra tad bit of information there. We're going to draw triangles by actually creating diagonals inside of all of our polygons. We can't cross our diagonals. Okay, so a diagonal goes from one corner of a polygon to another, or one vertex to another. So if you look at your triangle, I actually can't draw a line from this vertex to another vertex and go through the shape itself. That's a really messy line. Sorry about that. So that's why we only have one triangle inside a triangle. And we know that the measure of all the angles inside of a triangle is 180 degrees. Let's have a look at the quadrilateral. So that's the 4-sided shape right here. So I'm going to draw a diagonal from that corner to that corner. And you can see that when I do that, I have 2 triangles. So I've created 2 triangles in there. And 2 triangles will have a measure of 180 degrees each. So if I add those together, I'm going to get 360 degrees. And hopefully you guys remember from working in middle school with different shapes that a quadrilateral, a square or a rectangle, does indeed actually have 360 degrees inside it. All right, let's move on to our pentagon. So our 5-sided shape, which is here. And again, I'm going to draw as many diagonals as I can without crossing any of them. So I'm going to draw a line from here to there. I can also draw a line from there to there. If I draw any more diagonals, I'll actually cross over. So you can see in this one, I have 3 diagonals. Sorry, I have 3 triangles. 3 triangles. So if each triangle has 180 degrees, 180 times 30 is 540 degrees. All right. Our next one, our 6-sided figure, is our hexagon. So that one's up here. So again, I'm going to start drawing diagonals. I'll start from this vertex. And I'll go to that one. I'll go to that vertex. I will go to that vertex. And I can't go to that vertex, right? Can't do it. So I've got 1, 2, 3, 4 triangles inside a hexagon. And 4 times 180 is 720 degrees. All right, next one. My heptagon, my 7-sided shape is right here. So I'm going to go from this vertex. Oh, that's not a straight line at all. Let's try that again. All right. We're going to go from this vertex to that one. That original vertex to this one, down to that corner, down to that corner. So this time I have 1, 2, 3, 4, 5 triangles. 5 triangles. So 5 times 180 degrees is 900 degrees. I promise if I keep doing this, my handwriting's going to get better. Just bear with me. And the last one is our octagon. So I think I'll start in this corner this time and I'll go to there. So that's 1 triangle, 2 triangles, 3 triangles, 4 triangles, 5, 6 triangles. 1, 2, 3, 4, 5, 6. 6 triangles. And 6 times 180 is 1,080. All right, it's too hard for me to draw a 20-sided shape. So I'm going to try, oh, that's not 1,080. That's, here we go, 1,080. So I'm going to try to figure out, well, what's going on in each one of these? The ones that we already have filled in where we can see and we can count our triangles. So if we look, so I'm going to use a highlighter to help us see it. For a triangle, so a shape that has 3 sides, we were able to come up with 1 triangle. A shape with 4 sides, we were able to come up with 2 triangles. A shape with 5, came up with 3. It seems like there's a pattern here. It seems like that for every time we draw a shape, we can come up with 2 less triangles than the number of sides. And that's exactly what you should be seeing. You should be seeing that every time we do this, the number of triangles we create is 2 less than the number of sides. 1 is 2 less than 3, 2 is 2 less than 4, 3 is 2 less than 5, and so on. So once we get that number, then we multiplied it by 180. How can we write this in a formula so it's something we can use all the time? And that's what part B is all about. So we're going to actually try to write the formula first before we actually fill in this line of the table for an icosagon. An icosagon? Icosagon, there we go. All right, so I know that I want to multiply the number of sides, so minus 2 by 180. So in this case, for our icosagon, we're going to be saying 20 minus 2, that's going to give us 18, and we're going to multiply that by 180 degrees. This will give us the sum of the angles inside that polygon. So what number here did we kind of make up? What number here is changeable depending on the different polygon? It would be this number, the 20, right? So sometimes we just want to have a formula that we can use whenever we need it. So if I say to you, okay, find the sum of the angles in a 35-sided figure, you're just going to want to put in 35 there instead of 20. So we're going to rewrite this formula so that we can use it no matter what polygon we're working with. So we know we're going to be multiplying 180 by the number of sides of a shape minus 2. So we're going to use an n to represent the number of sides. That's supposed to be an n. Here we go. I'm going to try to make that n better because that's our formula. It's pretty important, so let's make it nice and neat. So we're going to have an n, and we always need to subtract 2. So this is our new formula. This is our formula for determining the number of sides in any polygon. So n will be the number of sides. All right, so let's go actually back and try to finish that chart. So if I'm going to substitute 20 in for n, I'm going to have 180 degrees times 20 minus 2 is 18. So if I multiply 180 times 18, I'm going to get, what am I going to get? That's a good question. I haven't actually worked that out. I'm going to get 3,240 degrees. So it's pretty cool. We actually have a formula now for figuring out the sum of the interior angles of any convex polygon. That's pretty cool. I should finish filling this in. And I think that's enough for one video. I'm going to make another video for the next part of this example and the next example after that.